Hello again, everybody. Another tutorial about how to find a short in automotive. Now, I came up with this block diagram, and I think this is essential. And when you start troubleshooting, you cannot spend hours just. If you think you have a blown fuse, you can't go through 50 fuses and just checking each fuse one by one. You have to look at the symptoms that you have. Are the lights on? Do the lights not come on? Is the engine cranking? Is the engine not cranking? Are the sensors a problem? There's these block diagrams that I have over here will give you a quick insight how the systems are connected. And it'll give you analysis how to troubleshoot. And I'm going to prove that. As you know, I have two channels. One is Joe Electronic Schematics, which is for educational for students learning electronics. And the other one is for automotive electronic schematics by Joseph, which is deep diagnostics, deep technical diagnostics of schematics in the automotive world, and that I think is much needed. Anyway, like I said, we have to differentiate between two things: a parasitic draw and a blown fuse, meaning I have a short or a dead short to ground. Dead short to ground means you measure low ohms. It means you allow more current than is supposed to be provided to that system. Obviously, a protective device, a fuse, or a circuit breaker, its purpose is to open upon the rated amps when the current flows more or allows more current to flow than the rated fuses is supposed to. 15 amp fuse, obviously at 16, 17, 18, its purpose is to blow, to protect, in this case, the fuel injectors, ignition control module, and power train control module, which is the computer. It's a protected device, obviously. So we look at this, and I tried to highlight and color everything in to make it a little more easier on the eye. Each system is represented by a fuse, its own fuse. The common fuse, or the biggest fuse here, is the 175 amp fuse coming over here. The battery. Shorts to ground will blow fuses, obviously. A parasitic draw, as they call it in the automotive world, for example, try to simplify it. If you leave your car overnight, you come home from work. You park it somewhere. You come the next day, which is maybe 8 hours later, 10 hours later. Obviously, you can't crank. If you have a voltmeter, or if you look at the gauge, you don't even need a voltmeter. The gauge in your car, all your gauges are, and most of them have it, it'll show you how much the voltage for the battery is. Also, when the alternator is on, it'll show you 13.5 volts, 14 volts. You go and you try to start it. The only thing that comes up are the gauges. If you happen to have enough voltage from the battery lasting to even supply the voltage enough for the gauges to start the instrument cluster. If you have about 11 volts, you could get the instrument cluster to work. If you have 9 volts, you might not. Well, anyway, I go in and look at the instrument cluster, 11 volts. How can that be? Left it overnight. Obviously, something drew means something was pulling current over a matter of time, sufficient enough to drain the battery. Now, those are two different things. A dead short to ground means I'm measuring from anywhere. If this will be connected to ground, then it obviously has to be connected to ground. To this point, I'm measuring 1 ohm or 0 ohms or close to that. That's a dead short, we call it in electronics. A parasitic draw means I'm not really blowing fuses. It's not a dead short. However, the rated ampage over time, instead of, let's say, 0.5 amps, which is 500 milliamps, it went up to 1.5 amps or 2 amps. That's not enough to blow any fuses here. However, over time, it does drain the battery, which is obviously a problem when I try to crank. Two different things to differentiate in electronics. Again, when it comes to parasitic draw, you will not blow fuses. You'll just have a constant draw draining your battery over time. So, the first one is the parasitic draw. Many ways to do it. You're not going to go and check the fuses if they're blown. If they would be blown, you wouldn't be draining the battery over time. So, the other aspect of it is you can always put a voltmeter across each fuse, put it on millivolts, which is the smallest scale, and you can see the voltage across it. But as I stress over time and over all my videos and the channels, the most best thing that you can use out of volts, amps, resistance to see how the circuit in test is being performed is always current. Current tells you how much current is going through the branches to the system. It's even more informative to me than measuring voltage. Doesn't necessarily mean if 12 volts, if I'm drawing more current, doesn't necessarily mean that the voltage will always be pulled down considerably, that I'll see such a difference. It might not always go to 10 volts. Maybe it'll drop to 11.5 volts or something like that. So therefore, we have to keep that in mind. So therefore,